Right now, as you listen to these words, the universe is exhaling, not like a tired man at the end of a long day. Not gently, it is exhaling the way a dying fire exhales, slowly, irreversibly, giving its warmth to a cold room that will never give it back. You cannot feel it, you cannot see it. But every second of every hour of every year that passes, the universe grows slightly colder, slightly darker, slightly more alone. The stars burning in your night sky are not permanent lanterns hung by gods. They are candles, and candles, no matter how magnificent, no matter how long they have burned, eventually go out. This is not a story about destruction. Destruction is violent, it is sudden, it is loud, it cracks and shatters and leaves wreckage behind. This is a story about something far worse than destruction. This is a story about silence, about the long, patient, absolute silence that waits at the end of all things, about what happens when the universe finally runs out of fire. This is the story of the heat death of the universe, the Great Freeze, the last moment when the cosmos, having spent every ounce of energy it was ever given, finally, mercifully, stops. Sit with that for a moment. Everything you have ever known, everything your species has ever built, every thought ever conceived in every mind that has ever lived, every war, every love, every monument, every prayer spoken into the dark, all of it exists inside a window that opened roughly 13.8 billion years ago with an explosion of unimaginable heat and light, and a window that will, in the incomprehensible depths of future time, slowly, silently, without ceremony, close. We live near the beginning of that window. We live in what future physics might one day call the Age of Light, a brief, blazing, extraordinarily lucky era when stars exist, when warmth is abundant, when complexity is possible, when oceans are possible, when forests are possible, when you are possible. But the universe is not sentimental, and the laws of thermodynamics do not negotiate. To understand the end, we must first understand what is being lost. Right now, the observable universe contains somewhere between 100 billion and 2 trillion galaxies. Each galaxy is a civilization of stars, some containing hundreds of billions of them. The Milky Way alone, your galaxy, your home, holds between 100 and 400 billion stars, each one a sun, each one a burning engine of nuclear fire so vast that the entire recorded history of human civilization could fit inside a single solar flare and still leave room to spare. Our own sun, that modest yellow star you carry in your eyes every morning, the one that warms your skin and pulls the tides and makes the wheat grow and paints the sky every evening in colors you never fully deserved, has been burning for 4.6 billion years. It contains so much hydrogen fuel that it will continue burning for another 5 billion more. 5 billion years. A number so large it has no emotional weight, no texture you can hold in your mind. The entire history of life on Earth, from the first trembling single-celled organisms in the primordial sea to you, sitting here right now, spans less than 1 billion years. The sun will outlive that entire story 5 times over, and then it will die anyway. And when it finally dies, it will not die quietly. It will swell, it will grow, it will bloat outward over millions of years into a red giant, a sphere of plasma so enormous that if you placed it where our sun sits now, its surface would extend past the orbit of Mars. It will consume Mercury like a candle absorbing a moth. It will consume Venus, and it will consume the Earth, not in an explosion, not in a collision, simply by expanding, by growing so vast and so hot that our world, this world, falls inside it. The oceans will boil away first, their water torn apart into hydrogen and oxygen and scattered into space. The atmosphere will follow. Then the crust will melt into magma, and the magma will vaporize, and the rock itself will become gas. And then the Earth, this pale, miraculous, stubbornly alive blue marble, this place where every human being who ever laughed or wept or looked up in wonder was born, will dissolve into the outer layers of the dying sun, like a word dissolving into the silence at the end of a sentence. 4.5 billion years of geology erased in geological time. 4 billion years of biology unmade. Every mountain range, every ocean, trench, every fossil record of every creature that ever crawled or swam or flew across this surface, gone, without a trace, without a memorial, without a single particle of evidence that any of it ever existed. And that is just our star, just our small, ordinary, unremarkable star in one of 2 trillion galaxies. After the sun swells, it will collapse, shedding its outer layers in a slow, luminous cloud called a planetary nebula, a ghost of gas and light that will drift outward for tens of thousands of years, glowing like a bruise in the dark. And at its center, what remains of the sun will contract into a white dwarf, a crystallized remnant, an ember the size of the Earth, made mostly of carbon and oxygen, radiating its last heat into the void. Slowly, patiently, cooling over billions of years until it matches the temperature of the space around it and becomes invisible and is called a black dwarf and is never called anything again. This is the fate of our sun. And the sun is not special. The sun is not the protagonist of this story. There are, in the observable universe alone, an estimated 1 septillion stars. That is a 1, followed by 24 zeros. And every single one of them, every burning point of light in every galaxy in every direction you could ever point, is going to die. Imagine the universe as a vast city seen from above at night. Right now, the city is alive. Every window glows, every street hums. The highways are lit from end to end. The skylines are brilliant against the dark, and the city stretches to every horizon and beyond, in every direction, further than any eye could possibly reach. It has been burning this way for as long as any of its inhabitants can remember, and they have come to believe, without quite realizing they believe it, that it will burn forever. Now imagine that city beginning slowly, over an unimaginable length of time, to go dark. First, the brightest towers, the blue supergiant stars, the ones that burn so ferociously they exhaust their fuel in just a few million years. They don't dim, they explode. Supernovae, the most violent events in the known universe, brief flashes of energy that can briefly outshine an entire galaxy of hundreds of billions of stars. They are magnificent in their dying. They seed the universe with heavy elements forged in their cores, the carbon in your body, the iron in your blood, the calcium in your bones. All of it was cooked inside a star that exploded before the sun was born. We are, in the most literal sense, the ash of dead stars. But after the light fades, what remains is either a neutron star, an object so dense that a teaspoon of its material would weigh 1 billion tons, or a black hole. The tower has fallen. In its place, a wound. Then the medium-sized buildings begin to fail. Stars like our sun, burning for billions of years before swelling and collapsing and cooling into their crystalline graves. Neighborhood by neighborhood, the city grows quieter. The light retreats. Then only the dimmest, most patient lights remain. The red dwarf stars. These are small, cool, extraordinarily frugal stars that burn their hydrogen with such careful economy that some of them will continue to glow for 10 trillion years. In a universe currently 13.8 billion years old, the oldest red dwarfs are still, in cosmic terms, young. They will outlive everything we have ever known or imagined by a factor of 1,000. But even red dwarfs die. In approximately 100 trillion years, one followed by 14 zeros, a number that makes the current age of the universe feel like a single heartbeat. The last star in the universe will run out of fuel. It will be a red dwarf, almost certainly. Small, dim, unremarkable. It will not explode. It will simply cool. the final nuclear fire in all of existence will go out not with a bang, but with the slow, quiet settling of a dying ember. And the universe, which once blazed with the light of a septillion suns, will become completely, permanently dark. No stars, no light, no warmth reaching any surface anywhere. If somehow, impossibly, something were alive at that moment, if some unimaginable form of consciousness were present to witness it, it would look out into a universe of pure, perfect, absolute blackness. Not the blackness of a room with the curtains drawn, not the blackness of a moonless night in the country. The blackness of a cosmos in which photons of visible light have not been produced anywhere for billions of years. A darkness so complete, so total, so without exception or horizon, that the very concept of sight would have no referent. Nothing to see, nothing to see by, nothing seeing. The city is empty, every window is dark, the streets are silent and cold, and will remain so for longer than the stars ever burned. But this is not the end, not yet. The universe, even emptied of stars, still contains matter, dead stars, cold planets, drifting rocks, diffuse clouds of gas too thin to ever collapse into new suns, and patrolling the darkness, growing slowly over unimaginable timescales, are the black holes. These are the last titans, the final inheritors, born from the deaths of massive stars, grown enormous over billions of years by consuming everything that came too close: gas, dust, stars, other black holes. They are now the dominant structures in a universe that has otherwise gone cold. They do not burn. They do not radiate warmth in any conventional sense. They are regions of space-time so severely curved by mass that nothing, not even light, can escape once it crosses the boundary. They are absences shaped like presences, holes in the fabric of everything, wearing the gravity of gods. They roam the dead galaxies, or rather, the galaxies come to them, the orbits of all remaining matter slowly decaying, star corpses and frozen planets spiraling inward over quadrillions of years until they fall across the horizon and are never seen again. The black holes consume what remains of the universe, the way a drain consumes the last of a bathtub's water. Slowly, completely, without hurry, without mercy, without awareness. For timescales that have no name in any human language, the black holes reign. Numbers written as 10, raised to the power of 30, 40, 50. These describe the years during which the black hole era persists, and they are so large that the entire current age of the universe does not even register as a rounding error within them. And then, impossibly, even this ends. In 1974, Stephen Hawking showed that black holes are not truly eternal. Through a quantum mechanical effect at their event horizons, black holes very slowly emit radiation. A faint, almost inconceivably faint, thermal glow, now called Hawking radiation. The larger the black hole, the slower the emission. The emission is so faint that for the largest black holes, the power output is smaller than the cosmic microwave background radiation currently filling the universe. They are, for all practical purposes, colder than the void around them. But the process is real. The mass leaks. Slowly, agonizingly slowly, the black holes shrink. As they shrink, they grow warmer. As they grow warmer, they radiate faster. In the final moments of a black hole's life, a period that lasts only fractions of a second compared to its total lifespan, it releases its remaining mass in a final burst of energy, a brief flash in the dark, and then it is simply gone. No remnant, no tombstone, a dispersal of particles into empty space and silence. The supermassive black holes, the ones at the hearts of galaxies containing the mass of billions of suns, will take approximately 10 to the power of 100 years to fully evaporate. Write that number out. Cover every piece of paper that has ever existed with zeros. You will not get close. But they will evaporate. They will all evaporate. And when the last black hole is gone, what remains? Particles. Isolated, cold, drifting particles. Electrons, positrons, photons of almost no energy. Neutrinos scattered across a universe so vast and so empty that the average distance between any two of them is greater than the entire observable universe is today. They will drift apart forever, pulled by an expanding universe that has been growing since the first moment of its existence and will never, under any currently understood physics, stop. The distances will grow, the particles will separate, and eventually, if eventually even means anything across these timescales, nothing will ever interact with anything else again. This is the heat death, not a bang, not a collapse, not a dramatic ending worthy of the story, just the slow, total, thermodynamic surrender of all structure, all order, all complexity to the indifferent mathematics of entropy. The second law of thermodynamics states that entropy, the measure of disorder in a closed system, always increases. A hot cup of coffee always cools toward the temperature of the room. A room always tends toward mess. A sandcastle always crumbles. These are not merely observations. They are laws, as fundamental as gravity, as inviolable as mathematics. And at the largest scale, the universe obeys them absolutely. Over time, all differences in temperature dissolve. All concentrations of energy disperse. All pockets of order, every star, every planet, every cell, every thought, break down into their component parts, and those parts drift apart, and the differences between places, differences that are the only thing that makes anything happen, anywhere, ever, vanish completely. The physicists call this state thermodynamic equilibrium, a condition in which the universe is perfectly, uniformly, featurelessly the same everywhere. No hot spots, no cold spots, no gradients, no flows, no reactions, nothing that could drive a process of any kind, not a chemical reaction, not a trembling of an atom, not a single quantum event of any significance. The fire that ignited 13.8 billion years ago. That first impossible flowering of energy and matter, that furnace which forged hydrogen and helium into all the elements of the periodic table, which built galaxies and stars and planets and oceans and forests and mines, that fire will be completely, permanently, absolutely extinguished. Not banked, not sleeping, extinguished. Gone in the only way that matters. Gone without the possibility of return. The universe will be the same everywhere at all times, forever. And in a universe where nothing differs from anything else, nothing can happen. Nothing will happen. For an eternity of eternities of eternities, stretched across distances that make the word infinite feel like an understatement. Nothing will happen at all. And now I want you to sit with a different question. Not how, but why it matters to us. Why you, a creature who will live for perhaps 80 or 90 years on a small wet rock, orbiting an ordinary star in a galaxy that is one of 2 trillion, should feel anything at all when you hear this story. We are brief. We are almost incomprehensibly brief. If the entire history of the universe from the Big Bang to the heat death were compressed into a single calendar year, the whole of human civilization, every city, every empire, every invention, every work of art, every atrocity, every act of love would occupy the last fraction of the last second of the last minute of December 31st. Not a second, a fraction of a second, a sliver so thin it would not be visible on any scale we could draw. And yet, here you are, aware, afraid, asking questions that the universe itself does not ask, because the universe asks nothing. It simply proceeds, it burns and cools and expands and darkens and does not, in any sense that physics can measure, care. You are the only part of this story that knows it is a story. That is either the most terrifying thing imaginable or the most extraordinary. Perhaps both. Perhaps the distinction doesn't hold. Every civilization that ever rose and fell did so inside a window it did not choose and could not extend. Every person who ever stood beneath the stars and felt small was right to feel small. The stars are older than us by billions of years and will outlive us by billions more. And even they are nothing against the timescales of the black holes. And even the black holes are nothing against the timescale of the final, empty, silent equilibrium. We are nested inside scales of time and space that reduce us repeatedly, recursively, to nothing, to less than nothing, to a perturbation so minor that the universe, in any honest accounting, need not have included us at all. And yet here, in this brief and burning window, something happened that may never happen again. In the long, cold dark that follows, matter learned to look at itself. The universe produced, from hydrogen and time and blind physical law, creatures capable of grief and wonder, creatures who could discover that they were going to die, not just personally, not just as a species, but cosmically, finally, absolutely, and feel the weight of that knowledge in their chests like a stone. You feel it now, don't you? That is not weakness. That is not irrationality. That is the correct response to correct information. The universe is ending. Not today. Not in any time frame that touches your life or your children's lives or the lives of any descendant you could plausibly imagine. But the process has already begun. The stars are already dying. The expansion is already carrying galaxies beyond the horizon of what can ever be reached. The clock is already running, has always been running, and it will not stop. The Great Freeze is coming. The last light will go out. Somewhere in the unimaginably distant future, the final photon of visible light will travel through an empty universe and strike nothing, and dissipate, and the darkness will be complete. And it will never end. But that light has not gone out yet. Right now, above you, through whatever ceiling or sky separates you from the cosmos, 100 billion trillion stars are burning. Right now, the sun is fusing 4 million tons of hydrogen into helium every single second, and has been doing so for longer than life has existed on this planet, and will continue doing so for longer than we can emotionally comprehend. Right now, somewhere in the universe, a star is being born, collapsing from a cold cloud of gas into a blazing new sun, lighting up a corner of space that was dark before and will be dark again long after. Right now, you are alive in the age of light, in the one brief, improbable, unrepeatable window when the cosmos burns and complexity thrives, and minds exist to ask questions that have no comfortable answers. Maybe meaning is not a property of eternity. Maybe it was never supposed to be found in the cold mathematics of how long something lasts. Maybe it lives only here, only now, only in the fact of awareness pressing up against the vast indifference of everything and refusing for one more moment to look away. The universe will forget us. The darkness is patient, and it will win, and it has all the time that will ever exist. But you are here first. Look up.